at 0, 0. So if you draw square root function, you have this dot, and it goes like this, and that point there, ABS min. And this will go forever up, climbing to positive infinity. Therefore no max of any kind in this one. You can have any combination. LN graph, again, no min, no max. So absolute value of x does have sine x and cosine x, infinitely many absolute max, right? And minimum. Does that? Because at 1 is the highest point, and you have infinitely many of those here and here and here and here. All of those at 1. Minimum at -1. That's sine x. So when you look at this, when you look at the graph, it is very easy to state whether it's min or a max, right? So if it's a frown, it's a max, right? If it's a frown, it's a max. If it's a happy face smiley, it's a min. See? Easy, right? Right. But then we have to distinguish between local and global, or absolute or relative. Then what happens is you run into a formula equation that you don't know how to graph. And then you start wondering, what should I do, right? I can't graph this thing. The calculator, let's say, you know, cell phone and everything, ran out of battery. You're on a desert island. Wilson left. So now it's only you, the equation, and a stick and a sand. You have to figure out the maximum point because you want to build that hut. And you can't do it because you run into ln of sine x squared, right? And where is the max? So it's an engineering effort. So we should have a procedure for this. And we actually do. So we are going to learn how to calculate where min and max are, if they exist, and using the equation simply by realizing that every time when you have min or a max, tangent line horizontal. Horizontal lines have what kind of slope? 0. So horizontal line have 0 slope. So you backtrack from there. So if I have a situation like this, we know that we have a horizontal tangent line. That should be common sense, right? Which means that slope is equal to 0. Now for tangent line, what is the slope? What is the slope related to what concept? Derivative, right? So slope is the derivative computed at the point of interest. And that is equal to 0. If I set the derivative of a function equal to 0 and solve for x's, I will get all the x values, which I will get all of the x values where we have min or a max occurring. That was good, right? Yeah, I took a step back. So that's the theoretical concept. So one more time, you discover this backwards. You have some kind of curve which has formula to it. So you have a curve, and anytime you have a min or a max, global, absolute, local, doesn't matter, right? So whatever min max you have, you always have a horizontal tangent line. Horizontal tangent line. Horizontal lines have a slope 0. We know that the derivative is the slope. So when you have a formula like y equal mx plus b or y equals x squared minus 7, you set that equal to derivative equal to 0, and x's that you compute will be these a's, the values at which you have min and max. Then you take those values, plug them in original problem to find y's, and you will have the point on the graph. Always remember, when you are looking for the point on the graph, to plug back in original equation, because the points are x comma y. Obviously, if you plug it back in the derivative, you're going to get back 0, because you just solved the equation equal to 0 to get those x's. So if you plug x's in the derivative, you will get 0. It's a good check, but it doesn't actually give you anything. So yeah. Okay. I think I found a way. Oh yes, I did it. When my pen disconnects, sometimes I can actually just kind of bring the pen in from the right and it will connect, which is weird. I just tried it, it didn't work. I discovered it by accident on Thursday, and what I had 5 disconnects since. It worked 3 times to reconnect it that way, which is awesome. So I don't have to unscrew it every time until I get the new pen. All right, so we all know that function x squared has what? In terms of min or max. It has the absolute minimum at?
No max.
0, 0. Great. And no max. Awesome. So we know this. But you know what? Let's calculate. So we know that we are supposed to take the derivative, which is 2x, and set that equal to 0, because we want to find all x's that will produce horizontal slopes, which are zeros. And here, x equals 0. It tells you the location at x at which this will happen. Now I will take this plug back and compute that y is equal to 0. So what I found is 0.00 at which I either have a min or a max. You know, I don't know which one I have. I don't know, because the calculation doesn't tell you that, right? We know, because we are awesome, that x squared graphs as a U shape, right? So it's a minimum. So you are able to do this for any crazy function I give you. I ask you, what is the min and a max here? This crazy logarithmic differentiation problem of the day, right? Here is your derivative. Set it equal to 0 and find values, right? I know it's crazy and we're not going to do it, but the idea is that it doesn't matter how crazy your function is. This is the procedure that works for them all. And the point of this whole thing was that you don't know whether the point you're getting is a min or a max. So you have to test somehow, right? You have to test, but you do know that you have something at that point. Now there's also another scary part here, which we are going to discover later, and that is inflection points. Sometimes when you do this procedure, the inflection point will pop up. What is the inflection point? Inflection point is change in concavity. What is that thing now? Well, x cubed graph. Does it have min or max? X cubed. Looks like a tangent, right?
Yeah.
Does it have min or max?
No.
No. What is this derivative? 3x squared. Set that to 0. What do you get?
0.
See? So when you do this procedure, it will tell you, that there is something happening at 0, and it doesn't necessarily need to be min or a max. So we can get one of the 3 things: min, max, or inflection point. Now that inflection point, that's a rare kind of thing, but it does happen. So you have to be careful about that. Cool. All right, so Come on. That's
You
it.
jinxed it. You ran it.
I know. Such is life. All right, so try. So here are the few questions for you. So find a all min max sine x a to the x and x cubed plus x squared minus 3. I just remembered I have to make a...
Got some fine. You know it, dude.
Weird question. Does anybody have any Tylenol or anything like that?
No, but I have a headache.
I mean, like, on you if it happened. Oh, that's in your car.
Potentially.
Probably. I'll probably not go to next week's like review thing because I'm not going to be conscious.
I'm going to that after killing me just so I get like something on track.
I'll be here.
Whenever he's left.
Oh, what a guy.
That would be like wonderful if you have that.
Yeah.
Also, the Notion's a name brand, right? Is that a name brand? Yeah, like what is it? Ibuprofen.
Yeah,
okay.
It's not an NSAID.
Well, no, I want it.
It's a downer.
Because I have a wrist issue, and the anti-inflammatory part is what I want. Like, if it was a non-anti-inflammatory, then I don't want it.
You know what? I'm happy about that.
Thanks for checking anyway, but
You don't want
It's just all for accident.
it's solved for, yeah, it's solved for after.
Yeah.
Did I really do it? Yeah.
What's the song like?
What is the most closing or locker? Repeatedly.
Is it this room?
Yeah. I don't know. It's like right here. Look in the draft.
Oh god, they're in the fucking fantasy.
Rats.
Yeah, dude, the grandma ones.
Hey, did you guys get one zero for the first one?
Yeah, I did. One, seven, zero. Or,
That's more than Sign X should have repeated min-max is dead.
Yeah.
Yeah. What's that? You?
Oh. No,
Yeah.
I wasn't paying attention. I heard what? That bang, right? I don't know, dude.
See, it wasn't annoying before, but now that he's pointed it out, I'm going to notice it, and now that I know I'm going to
See, that's why
Now it's their fault, yeah. We should petition to get it removed.
Ah, dude.
It's fucking massive protest. Like,
Yeah,
taking
dude,
the
you go out
last one.
there and get whatever that is. It's not like,
Remove the slight banging and free something.
yeah. That's a nice chain. Probably like some dude just staring at you for the time. So.
Should get shot.
No, he's got a little bit of pump there, and every now and then his hand
Oh,
apart.
on the side.
Just get a little apart, hits the wall, causes the banging.
I mean, if he's in a bed, you know, doing that, I mean,
I think he has to
You live your dreams, dude. Like, he's outside the system. He's doing him. Outside the system. Yeah, right. Nope, fuck off.
You already ate brownies.
Oh my god. Oh,
What said you did during one?
the test day? Yeah, you do my seven. The seven is pretty fancy. I try not to buy 7 yen. I'm sorry, fancy.
Like the list or the top?
Oh, the list. Like, as a unit, it's pretty fancy.
Someone's accused Obama of wiretapping his phone.
Borderlands 1 is good. I don't know why. I just couldn't get into 2 of them.
I remember hearing the original for Xbox. Oh my god, I was a kid.
Oh, like
That was
the remake of Doom, like the pixelated one, or like Doom 3? Like the original.
Oh, dude, fuck you, it's right.
Yeah, the original. I still have my original Xbox.
It was kind of like Windows 95. Oh, yeah. Yeah, that's what I was asking. Because I think Doom 3 was also for
Doom 3 kind of sucked though, compared to like.
I mean, I'm not saying. I'm just like trying to think of a console.
I have Elder Scrolls from my PS4.
Moral.
So lag so bad. Yeah.
Dude,
It
I heard
was. It sucked so
It's
much.
designed to
And-
be played with the controller, right? But like,
What?
you can't do inventory management with 2 analog sticks. So like, there's no economy. So like, all of the late game like gear and shit is just like,
What, Elder Scrolls?
yeah, on the consoles it doesn't exist.
Dude,
Oh,
if you want to play an
yeah,
MMO,
I'm sorry.
like,
Because they make you
if you want to
pay
play
$50
casual one, play like
for the
Diablo
game.
3 and Space
And then
Jam
like
well.
another $50
Want to go
for add-ons,
hardcore, play
right?
like,
Yeah,
just play World of Warcraft.
And see,
I mean, like, I don't.
that's the thing. Like,
I
if
kinda like
a game
Black
has like story-based DLC, like I need it.
Yeah.
I need it.
My friends are gonna get level 1 because, you know, it's
free.
Dungeons and Dragons.
That game is cancer.
What about DDO?
Whoa. What?
Whatever for anything.
No, World of Warcraft.
Sense of subject.
That was my winter break, like, the vanilla WoW private server, and just like,
I have no
You don't
I'm
like
actually
it?
playing on a WoW private
I have
server
an
right now.
issue with
You don't like it?
Blizzard.
Sorry?
You don't like the game?
That wasn't publishing 90 ads because now you look
I
at
barely play it, but my friends make me get it.
I'm horribly biased.
and
Because
then
I
no one
play a lot
plays
of real
it,
D&D,
it's like,
and it's just a video game with a D&D license slapped on top of it.
I think
Like, I just don't like any time when a franchise just poured out.
that's like all of Blizzard.
Yeah.
Well, when I got home, it was downloaded on my PS4, so.
They just put it on
Somebody
it for
got
you.
my PS4 and downloaded it for me. I was like, well,
I guess I'm playing this now.
Yeah, so
No, I don't play.
console war, right?
I don't
Like,
have
yeah.
I think
Are they even a thing in the console?
I don't think Xbox One has like any purchase at all because if you look at like PlayStation SharePlay, you can just link your PlayStation with somebody else's.
The only console I would ever get is a PlayStation or a handheld. Like, there's no.
Buy a PC for.
I mean, yeah, that's what I play on, but like, if I wanted to get.
Yeah, you're on Steam.
Huh? Yeah.
I might
What is it? You're right now.
Justin, Vicky, Ryan, and Emily and Jenna want to get together
I'm not on Steam much, but I'm on my PC like all the time.
What is it?
Even so,
Did you ever play Killing Floor?
no,
Yeah, I just-
my friend got it though, and I was just watching him.
Dude, fun ass
You
game.
know what? That's for the PS4. Really want to play Let It Die.
Yeah, he just opened
Like,
it.
I haven't heard of that.
Tried to restart. He'll say
it's
yes. But the thing is that he's in New York,
what
so
studio is that?
tell him
The
I don't
same
know.
studio that made No More Heroes
That's
and
what
like
it's
Killer
after.
Your
He
Dad.
has to do my online testing.
Oh, so like mostly console
I
games.
don't know.
Yeah, Killer Your Dad
Just
is
say.
awesome.
The last time I played a console, it was Halo 3 for the Xbox 360.
Yeah.
Yeah, my 360 is now the right, like the
Are you trying to do
Netflix
it today?
machine.
Yeah, it's a more DVD player if you have a DVD.
Tomorrow? What's Monday?
Yeah.
Monday?
I don't know. Wait, hold on.
My family just has a really shitty PC in our living room. We just use that to play stuff.
I feel really bad because like I've got an i7. I've got an i7 6700K running with the GTX 1060.
Because last time
I bought it myself. Like, I bought it
Hardwired it
myself.
test.
My dad has
What?
the wireless router or whatever.
Dude, look at this
So bad.
dude.
He won't let me buy a new one.
If you want to go crazy, then running Ethernet cord is not difficult. If you're
Oh, I
allowed
don't know
if
how
you're
to
allowed to
watch
hole in
it.
your house.
See, I have like a toaster
I
that,
just
like,
because the
like
library
a little bit better than
Yeah.
toaster. No, like, don't get me wrong, this is my first
Yeah.
like,
No,
before
I
I
want to
built
run
this
Ethernet.
computer, I had a
I don't want to
2010
know what else
MacBook
like.
Pro.
You won't even
with
notice.
a 13-inch.
You
So
have
then
to
I
get
got Ethernet
150
bridge.
gigabyte hard drive.
I was running like a 2.2
That's always
gigahertz processor.
But now like the router connection is something.
I was like,
And like
I
the
didn't
amount of
even
times
never
I'll
do
broke
it.
Is your dad one of those people
I've
that's
got
renting
five
it?
routers, right? On that laptop, I was
No,
getting 1 megabyte
Do you guys actually own it?
Because I don't think
Router.
we
With
have-
PC now, I'm going like 7 or 8.
Yeah,
My
right.
dad tried
It's like,
He won't let you buy another one. He won't let you buy one.
I'm not one of those people though. Like, I do play games. I
He didn't want to give me money.
I said I play Minecraft.
Like, I don't
Oh,
care.
it's one of those situations.
I'm using
Or
Minecraft
like-
to
I'm
like
going to
teach
come home with
myself
one.
Like if you
Oh,
invite someone to
and
go out
I'm
to eat or whatever,
making-
and
I'm
they can
making,
afford to
like,
go out
plugins
to
and
eat,
shit.
if they couldn't afford it, you would pay for them. But
Plus,
since
it's
they can
like-
afford it, if they're not willing to pay the money, they can't go out and eat with you. Because you're not going to pay for it, they can afford it, and they're not willing to spend the money on it.
I don't know. All my dad's money came from my dad was for my dad was
Like right now, my
like
friend,
I had a job.
I'm part of a team that runs like 6 different engines basically. And they're pulling like,
This is something we make with.
they used to be pulling like
Oh.
$3,000 a month in donation.
But we
I
managed
don't
to
know.
like,
I just like
I
Very good.
Holy
and
shit.
stay there.
Everyone's been buying.
And then
What?
So I feel like the test when you take when you do like the runway stuff, because like I feel like I could fail if I do the wrong thing.
Yo, environmental bubble.
Alright. So, did we get it?
Yeah, of course. What was the question?
I'd rather have like
So let's see the power of this stuff. We start with sine x. What's the derivative of sine x? And we set that equal to 0.
Yep,
When is cosine equal to 0?
at 1.
And negative 1.
Negative. Go infinity.
No.
Okay.
What are the values of cosine that will produce 0?
Oh.
Exactly.
Yeah,
Pi over 2. And what else?
And
Yeah, plus like QN, right? 2 pi over.
So, we have infinitely many solutions, which is pi over 2 plus minus 2n pi, n pi just, because it's happening every n pi. This is infinitely many solutions. Which is exactly every place where sine is maximum at 1 or negative at minimum 1. Or minimum at negative 1. There we go. I put the words in the right order. Awesome. Part B. Y equal e to the x. So what's the derivative?
E to the x.
And now when you set that equal to 0, what do you get? What do you get?
The answer not been 1.
1? Not 1. E to the first is e. Because 2 to the first is 2.
Oh, into the 0.
Yeah.
Yeah, it's never equal 0.
It never equals 0. Very good. No solution. which means no min, no max. If you are to graph this, the graph never cuts through x-axis, so can't create any zeros. Awesome. And C, what was that? X cubed plus x squared minus 7 minus 3. What's the derivative?
3x squared plus 2x minus 3. Oh yeah, you're right.
Equal to 0. And to solve this, we factor out. Remember, we have to factor things. So factor out x. We have 3x plus 2 equals to 0. X equals 0 is one of them. And negative 2/3. Very good. So we have two solutions in this case. We'll have min and a max. Cool? Of course, it's math. So now we are going to define something. But guys, you have to be careful. Is derivative going to detect every single one? Sure. But are there mins and maxes that exist that derivative cannot detect? And the answer to that is yes. You see, when we talked about differentiability in general, we said that y equal absolute x is not differentiable at 0. But what do we have at 0? A min. And the derivative does not exist there. Y prime d and e at 0. We have min. Another example. I don't know, I'm not sure which function this would be. I could look it up, but I'm lazy. I'll just call it ninja.
What's the derivative of ninja? Samurai?
Look at it. It's this spike, like this. So these are linear lines that come in at 45, let's say, and create a spike. But we now have a cusp that looks like this. These slopes are infinite at this point. They're infinite. So the slope of the tangent line is equal to infinity. Derivative does not exist again. We have max. So we see that both situations occur. You have min and you have a max, but you did not have the derivative at all. So these two rules complement each other, and we get one overall rule which will define something that we call a critical point. And that critical point is where we are going to get one of these interesting things happening. So, critical point. An interior point C of the domain of F So interior point, which means one of the inside points of the interval where you have the domain, at which f f prime of C is 0, or f prime of C does not exist, is called a critical point. Of f. It should technically, in order to be called a point, it should have x comma y. So I'll just put that. It's called critical number, but then this book is awesome, so it's a critical number because it's only one value. I gotta burn off these brownies, so I'm just gonna keep walking around. The handwriting is gonna improve actually. So what we have is the critical point, because me standing there is not gonna do much if I just walk around. So now when you have a function, you will have the derivative, and then if derivative is 0 or does not exist, you will have critical point at that place. It could be min, max, or that inflection point, which we will decide. I just realized that I sat down, which is the reason. Please let me know if I do that again.
We'll start screaming at you.
Yeah.
There's no need.
There's
No need to scream, because I usually punch. It's the automatic reflex. I can't fight that. Sorry.
Put paper out of you.
That's just worse.
So you get exercise when you run after us.
So let's take a look at a few of these beautiful examples here. So here's a 26. Locate all critical points, and then we'll figure out what we can do to figure out whether they're min or max. I have to, because there's no more. We're out of brownies in the class. Should we vote next time for the exam 3 immediately?
Brownies every time. I'll basically just choose whatever date you have the sun.
Not when Nick dies from like a massive heart attack.
From eating brownies.
Yeah.
He just has to last up the semester. What, from eating brownies? I'm just forced to eat brownies.
Yeah, you have a legion of subscribers show up over here.
All 2?
Yeah, exactly. Well, 3 now.
I think I subscribed. I don't know.
That tells me the termination. All right, let's see. So we have this as function y, I hope. This is problem 26. So x to the 4th over 4 minus x cubed over 3 minus 3x squared plus 10 on negative 4 to 4. As you can see, we have domain, which is restricted, right? It's a closed domain from negative 4 to 4. This is a polynomial, so domain for this would be negative infinity to positive infinity, right? All right, so let's go. Take the derivative, set it equal to 0. So we are going to take the first derivative, set it equal to 0, solve the equation, plug values back in to get y values, and then we'll see what's what.
recipes at ln, and you said it's copy paste the bottom and then derivative of the top, right?
Yeah.
And then just go through like that. Because I'm getting practice at that.
But you can, this is all one term because that's
that's
what's for multiplication, division,
so that
yeah.
would just be ln of it.
Yeah, ln of everything, so it's defeats the purpose in this case. Sledgehammer, sledgehammer.
I mean, that's like that one theorem, that one specific one. His name I can't remember.
So I hope you all have same numbers 0, 3, and -2. We're good? Now we're going.
What sound is that coming from your touchpad?
The
Is it static I hear?
fan.
Oh, okay. I'm crazy.
So y of 0 is equal to 10 because when you plug 0 for each x, and we have the first point to be 0, 10. Again, have no clue whether it's a min or a max. I just know that there is something there. Now we plug 3 in. 3 to the 4th, 27 over 4. Minus, no, that's 81 over 4, sorry. 27 over 3, that's minus 9. Minus 27. And then plus 10. That's negative 26. 81 over 4 minus 26 over 1 times 480, 104, 81, 104 over 4. What would that be? That's 23, right? Over 4. So the point is 3, negative 23 over 4. And the last one is when you plug in negative 2. So I plug in negative 2, x to the 4th is 16 over 4 is 4. Minus 8 plus 8 thirds, because negative odd exponent derives. Minus 12 plus 10. So that's 14 minus 12 is 2. Times 3 is 6, 14 thirds. So negative 2, 14 thirds. Cool. So I have critical points, x, y. I found critical numbers by setting derivative equal to 0. We know nothing weird happens here in terms of, denominator being 0 or anything like that. So now what do I have? I have 3 critical points, and I can actually figure out which one is which if I place them on the graph and look at their heights, because I know that polynomial has to be smooth in some sense, right? It has to do that, something like that. So if I'm to place this on a graph, I have 0 and 10. That's 0 and 10, say. Then I have 3 and negative 23 over 4. That's like 24 over 4, which is almost 6. So about here somewhere. And for negative 2, I have 14 over 3. So that's like 15 over 3, which is 5. So halfway to 10, something like that. So the graph has to go through these points. So I hope you see that it has to go connect this way and it has to connect down, right? So we found that our first point is what kind of max? Relative max. At 3 we have absolute min. And at negative 2 we have relative or local, yes. Why are you sorry?
I didn't say.
Doesn't matter, relative or local. The words are equally fine. So this is how the graph looks like. Now, what you can do anytime is just go to Wolfram Alpha and actually graph it.
Wolfram Alpha. So useful.
Yeah. Well, there's also, have you tried Symbol Lab?
I have not.
Because these guys now charge for steps and so on. Symbol Lab, I think this is how you spell it. Yes. So Symbol and Lab, but use just one L. It's all Math Solver. Enter a problem. I think you type graph, and then you type in your equation. What was the equation? Let's see. But this is a little bit more annoying to type, I think, because you have to point shoot every time. X to the 4 over 4, so that's 0.25 x to the 4. Ooh, awesome, I can do that. Minus 1/3 x cubed minus 3x squared minus 3x squared, and then plus 10. Go. I hope that works right off the bat. Where's my graph? Beautiful. So, I mean, clearly mine is much better, right? But there it is. Now I'm interested in the related part, where it says inverse of it, parity, critical point. What's going to happen if I click on this thing over here? Let's see. Negative 2, 0, and 3. So technically solves the whole problem. Right? Gives you the graph, gives you the whole thing. And actually this one shows steps. Wolfram Alpha, I think you have to pay like $5 a month or something like that. So Symbol Lab. Obviously when enough people switch to this, then they're going to start charging. Right now it's free to get people in, and then
Yeah, it's always a business model like Discord, the latest like, voice chat for gamers, completely free with no ads now. Once they have enough people, they're of course going to start adding advertising.
exactly. So you have all of these. So that's what you can do for this. Perfect. Let's take a look at another problem that you might enjoy, because you love this stuff, obviously.
Obviously. If you don't love math at this point, what are you doing?
Can I quote you on that?
You may, as long as the prime time.
So this time it worked. What would you... Beautiful. Beautiful problem, 34. Y is equal to x squared minus 2 ln of x squared plus 1. I know, you got excited, right? So all you need to do is to take the derivative set equal to 0, obviously. Again, logarithmic differentiation doesn't work on problems with plus and minus. It works on the product rule, quotient rule, and the value of problems. Yeah, we should start.
See you next week.
So the derivative would be 2x minus 2 times its ln. So we immediately put the division line, copy the argument as is, and put its derivative on top. And now, since I know I need a factored form, both of these have 2x. I'm immediately going to factor out 2x and have 1 minus 2 over x squared plus 1, like this, because that is what I have to set equal to 0. Now that's easy because I have 2x equals 0 and 1 minus 2 over x squared plus 1 equal to 0. And this one is 0, so that's the first. Second one is clearly 1 equals 2 over x squared plus 1. Cross multiply both sides. X squared plus 1 equal to 2. x squared equal to 1, from where x is plus minus 1. So I have three critical numbers, x equals 0. Well, let's sort in order. -1, x equals 0, and x equals 1. I have three answers. Plug each one of these in the original equation to see what we get. So -1. Plug in -1. It's going to be 1 minus 2 times ln of 0. How much is ln of 0? Nothing. It's negative infinity, right? So does not exist. So this is vertical asymptote. So what we got? A vertical asymptote there. ln of 0 is where the vertical asymptote is, guys. It has the vertical slope. Then what we have? We have x equal 0. When I plug that in, I will have 0 minus 2 ln of 1, which is 0. So I have 0, 0. And then I have another point at 1, which is going to give me 1 squared is 1 minus 2 times ln 2. Now how much is that? No, we can compute. ln 2 is a number. What your calculator says for ln 2?
0.698.
Times 2
1.386.
minus 1.
0.386.
There we go. So these are the values. Now I can graph that quickly. I have a vertical asymptote. I have a 0, 0. And I have -1 and negative something. So this is where 1 and -3 something right there. Now, how do I connect these points? How do I connect these points? This is a little preview now of 4.3 actually, because I'm trying to sketch the graph. Well, we don't know whether these are min or max. So I don't know whether I should put a smiley or a frown through it. So what can I do? I can compute a point nearby. And if the point is above, it's going to be a smiley. If the point is below, it's going to be a frown. So pick a point between -1 and 1. So what are the test points? Clearly, -1/2, +1/2, and let's say 3/2. So these are the test points. And you plug them in original equation, see what kind of y you get. So let's go. What do we get for -1/2 in original problem? We get -1/2 is a quarter, so it's 5 quarters. So ln of 5 quarters times 2. Where's my Wabbit? There it is. All right, so let's see. I have 0.25 squared minus 2 times ln of, I said 5 quarters, right? The answer is negative whatever. So this has to be a frown, which means it's going to go like this, and then it's going to go into that one, and then I think it should kind of bounce and follow like this rather than go shoot up, because I think we have a horizontal asymptote here. If you send x to infinity, yeah, you might have in this case something like this, but you get the idea. So we know there is a max here and there is a min here. We know it's a local min. Now I'm not sure if this is going to go up. I don't think so it will, but if it goes up, then it's a relative min. If it actually follows the asymptote, it's the absolute min, max. Sorry, max. And we can obviously graph this in SimLab and see how it looks like and so on. But it's interesting to see, you know, try to come up with on your own. The last idea, the last concept of this section is when you are on the restricted domain, closed domain, let's say like we had earlier from -4 to 4, your absolute min and max could happen at those points as well. Let me give you an example. Well, square root, I gave you an example. So square root has domain of 0 included to infinity like this. And we know that the point 0, 0 is ABS max. Min, sorry. Min. We know that. Now, what else do I have? Let's say, this is a terrible Y. Yes, better. Let's say I have a function that looks like this. You can see that this is ABS min and this is relative max, right? Because this is absolute max as with relative min. So endpoint could be your absolute min or max if you have a restricted domain. So you have to compute those as well. So you will find few, maybe 1, maybe 2, maybe 7 critical numbers. So those critical numbers give you min and max. But then you also have to compute the endpoint and check, compare all the y values. The highest of all y values is the absolute max for a problem, and the lowest of all y values is the absolute min for a problem. That should be common sense. So when you have this situation, you have to compute the endpoints as well. So let's see. We have something cool here. Here, 40. Y equals x over x squared plus 3 squared on -2 to 2. So find all min max and figure out which one is absolute, which one is min, which one is absolute max. Because when you find them all, including the endpoints, the highest one of all is absolute max, the lowest one of all is absolute min. Smooth.
Look at that dude.
You.
He's angry.
Someone banging their head against failed.
They're stuck in there and they have to listen to 5 hours of calculus.
It's test next week. Yeah, during the spring break.
Well, then maybe you shouldn't be saying.
Poltergeist, I'm moving from the screen.
Oh yeah, pick a solution that makes sense.
Yeah, dude, that's no fun. No one likes that.
The wind just got stronger. Like it wasn't that bad when it got here, but it was like not quite so.
So once we get out of the classroom, you find out that that part of the building is missing. How crazy that would be? Just go there at the end of the hallway, it's like you can see 3 floors down the level.
That'd be pretty cool. I don't have thoughts really fun.
Oh, I didn't make a square.
Technically, just rip the page out.
Yeah.
So we can deal with this derivative with logarithmic differentiation, right? It will give us the factor form, and then we plow through that. So the derivative using logarithmic differentiation is going to be cut and paste times 1 over x minus 2 times, so 4x over x squared plus 3. So that's the derivative using logarithmic differentiation. And we just say equal to 0. Now this is, it looks bad, but actually it's not. Because we have x over x squared plus 3. Now if you use the quotient rule, that's fine. Right? It's okay to use that. We have the first equal to 0. Guys, denominators don't matter because when you cross multiply, denominator multiplies into 0 and just dies. So you just get x equals 0. That's done. The second one is always tougher to solve. So from here I have 1 over x equals to 4x over x squared plus 3. Now cross multiply. We get x squared plus 3 equals to 4x squared. And then move everything to the left, so it's 3x squared minus 3 equal to 0. Factor out 3, you get x squared minus 1. And we get x equals to plus minus 1. Awesome. So we again have x equals negative 1, x equals 0, and x equals to 1. And we plug those into original problem to see what's what. So when I plug in negative 1 in original problem, I get negative 1 over 16. When I plug in 0, I get 0. And when I plug in 1, I also get negative 1 over 16, or positive 1 over 16. So I have 3 points so far. -1, -1/16, 0, 0, and 1 and 1/16. Now remember what I said. When you have an interval, like we had here from -2 to 2, we have to check those points as well in original equation. So x equals -2 will give me, and I also have x equals to +2. So that's this part here of having the domain shortened to this. So plug in -2, we get -2 divided by 49. And the second one is +2 divided by 49. So in addition to these points, I have these points here, which are -2/49, and +2 and +2/49. So which one is smaller? 1/16 or 2/49? 2/49 is smaller, because 2 times 16, right, to make the same numerators, let's say, you should really make the denominators the same, but you can also do numerators and then think the opposite way. So if I double 16, I get 32, so it's 2/32, and 2/49, well, over 49 is smaller than over 2, and I have 2 pieces each. So there we have it. So this is smaller. So the smallest value is this. So this is ABS min, because it's the smallest y. And by the same token, this is ABS max, for again the same reason. It's the largest y. We have 5 points. 3 we have from the derivative, and 2 we have as endpoints. Word problem. Business. Economics stuff. Let's talk about revenue. What's revenue?
Money. Money coming in.
All the money coming in. Yes. So that's all the sales you make. So the money you get. Now, is that all money you get to keep?
No, it's not profit. It's all money.
No. Profit is the money that you keep. Revenue is all the money, and then you have to take away the cost. Take away the cost. That's it. So it says maximizing revenue. A sale analyst determines that the revenue from the sale of fruit smoothies is being given by R of x. So revenue. R of x is -60x squared plus 300x, where x is the price in dollars charged per item for 5 items. Find the critical points of the revenue function, determine the absolute maximum value revenue function, and the price that maximizes the revenue. So we are looking, right, for maximum revenue, that's the y, which comes in from the x, which was created by the critical value. So I know, word problem, but this is the easiest problem that we have today for this section, right? You just take the derivative of r, set it equal to 0. So this is nowhere as crazy as the ln problem, or 1 over x squared plus 3, whatever the hell it was. You're dealing with a polynomial.
Sold the pitch.
The walls of houses.
Oh god.
Moves apart, tears the walls.
Don't do that.
Why?
What's so bad about that? When I'm saying, we have this rocker in the bio lab, and during bio too, I like caught it out of the corner of the eye, and I thought our experiments were falling to the ground, so I like jumped to try and catch it. Like,
I'm gonna deconstruct the wall.
you make it into a tower.
But,
Hey, Trump card.
I am so angry that I didn't take. So when long time ago when I worked as a busboy at a restaurant and then as a food runner, they gave me a company tie, and the company tie was Donald Trump tie. And I was for years working there joking and going like, you're fired, you're fired, you're fired. Like, how awesome would it be to have that tie right now?
You're
Fired.
You're deported.
Yeah, beautiful, beautiful.
Damn white.
Just make it worse.
We're being deported to Mexico anyway.
How did
How'd
that
that
I
work out?
didn't even know that existed.
Neither did I.
How'd that work out for him?
not well, like they asked, like he was like part of like the whole state thing that they had against him because some of the degrees that they got after they graduated weren't like viable for the
Like what degrees? Like,
Yeah, that's why it has to be.
How to be like, I don't know, it was like they offered a whole bunch
That's
of like,
one of the things that you have to worry about, guys, when you're transferring out. It's not just the price, but it's also is it accredited institution, which means if the degree actually works at it when you're done, you might pay $60,000 and work 4 years, and then you have your degree, which actually no one cares about because it's not accredited. This school, we go every 5 years through accreditation process, so we make sure that your degrees are valuable and the organization reports on accreditation and go to 4-year schools. So you can't just open up university and go. And then there are universities for profit, there are these or that, so there are different types of places. So if you're looking for a transfer institution, there are these massive ones that are, like Rutgers that are, fine by default. But then anytime you look into some kind of smaller school, I have like 700 students. Why?
Like, unless they were really good at accreditation, they're kind of worthless.
Yeah.
It's only worth the paper it's printed on.
You see the RPI $65,000, per year. But then when you look, who recruits in that school, Boeing and GE, right? All these huge companies. So you have to check all of that stuff, not just this school's cheap or this school's nice, too small.
Reputation matters. Like, I want to be a teacher, so my best two options are either PCNJ or Kane College.
Yeah, or Montclair.
Or Montclair good too.
Montclair, we have 3 actually. People will be the most money.
But the example is like Kane's not as good for other professions, but they're good for teachers.
Yeah.
they used to be good for like,
Each school is good for some.
A couple years ago, they were actually in danger of losing their accreditation. They didn't lose it,
Yeah,
but they were in danger.
I don't know, I gotta look around.
I should never go to Keene unless it was specifically for
for
education.
education.
Yeah.
Keene was actually used to be, my dad got a degree at Keene, and it was like a really good mechanical contracting degree that.
It changes, it fluctuates. So you want to study business, economics,
And now they don't even know.
and if teaching or some kind of humanities, performing arts, that's Montclair State. Bruce Willis is right there.
I'll keep that in mind. I'll think about
Yeah,
that.
if you want to do prop.
Best Chris movie ever. Backward.
So, to solve this quickly, we have that the derivative is negative 120x plus 300. We will set that equal to 0. And we have that negative 120x is equal to negative 300. X is equal to 30 over 12 divided by 3, 10 over 4, which is 2.5. Right?
Yep.
So now I have three values to check. X equals 0, X equals, I'll put 5/2 because I'm awesome, and then X equals 5. Yes.
You have 5 products and you have 2.5 products.
That's an average. Negative 60, so that's negative 30 times 25 plus 150 times 5, so 6, right, 75, negative 750 plus why is it giving me 0 as well? 25. It also gives me 0. That makes no sense.
That's what I got.
I'm plugging it in the original equation, so I'm not plugging in the wrong equation. It's just you have the same points, right?
Yeah.
And I got 0, 0, 0 for all of them, and yet I'm plugging in here. Something is wrong because you're not supposed to get 0 for 5.
25 times negative 15. 5. No.
Yeah, I know. And what was this one?
300.
Now, where did I make a mistake? I guess getting up
Yeah.
this morning.
Go outside, it's so cold.
Oh, because it's divided by. All right, fine. 2 squared is 4. All right, there we go. All right, cool. So we see after messing up on the easiest problem that we have these points which are 0, 0, 5/2, 375, and 5, 0. What happened? Why over 4? I did. That's where the 2 came from. I used one of the 2's to cut 60 into 30, and the other 2 stays. And then the 2 from 5/2 cut 300 into 150. All right, cool. So we have these 3 points. Now, what's min, what's max?
375 should be max.
Of course. Great. And now we're just going to practice derivatives. Oh, how much you love this stuff. Exactly. What's 0 raised to 0? Aha! That's gonna be chapter 4 for you to discover. Could be anything. Depends which 0 is bigger. What does that mean? What's infinity minus infinity? Aha! No? Again, depends which infinity is bigger. So we are going to go and find infinity minus infinity is negative infinity, infinity minus infinity is positive infinity, infinity minus infinity equals 3/4. That stuff is coming up in chapter 4. You will see that stuff. And you know what? You are going to find 0 raised to the 0 to be like e cubed. Yeah, I know. Because when you think about it, 0 raised to any exponent is 0, right? Because it's 0 times 0 times 0 times 0. And then any number raised to 0 is 1. But then you have 0 over 0. So one is pulling to answer to be 0, the other one is pulling answer to be 1. And then you compute like e cubed. Awesome. I love it. So we'll see all of those things eventually. Now, let's take a look at a few more of these that have wonderful equations for you to solve. For instance, 2x everything raised to x. So let's find points for that. On domain 0.1 to 1. How do we find this derivative?
Question.
Good question, right? I have a lot of cool questions like this. We put like 6 of these on a test.
I will bang my head against the table.
All right, go on. Yeah, it is connected again.
Like reloading the gun in one of those arcade games. Have you tried deleting the
Hmm?
Have you tried deleting the thing?
Mm-mm. So we first take the derivative. We have a product rule on the right-hand side. And we set this equal to 0. Now before your head explodes, we have this. You hit both sides by the x square root. It's not a problem. You got this.
Alright, well, same things to do.
And then on the other side we have so now we e both sides, right? Great. have this and that. Plug in original equation to get the rest. Which is the issue, because look what they say. Look at the domain. 0 excluded, right? So due to restricted domain. So we only worry about the other one. So what's the other one? The other one has to be 2 times 1 over 2e raised to 1 over 2e. So that's 1 over e raised to 1 over 2e. Like this?
Yeah.
You sure you plug everything in correctly?
No.
As I feared.
We just need to believe.
Open parenthesis 1 divided by e, close parenthesis, raised to, open parenthesis 1 divided by, open another parenthesis, 2e, close whole bunch of parentheses, 0.831.
Oh.
832. So I have to find x for 0.1. I have to find x for 1 over 2e, which I did. And for 1. So let's go with the 1. 1 is the easiest. So that's just 2. Because you get 2 times 1 raised to the 1, which is 2. So over here we have a point 1 over 2e, 0.832. Over here we have a point 1 and 2. It's clearly bigger. The only one we need to do is the 0.11, which is 2 over 10 raised to 1 over 10, right? Because 0.1 is 1 over 10. This is the 10th root of 1/5. Which is the 10th root of 0.2. Point 2 raised to, open parenthesis, 0.1. So the point is 0.1, comma, 0.851. No coffee. So 1 over 10 or 0.1, 0.831 if I remember well. 851. What's what over here?
2 zeros and then everything.
Absolute max.
Global.
Global. Anything else? We only know where the absolute max and absolute min is. We don't know what point 1 is. And that's it. The highest of all values is absolute max. The lowest of all values is absolute min.
So you can never, like, well, you will.
You can. Next section.
Oh, okay. As long as it's not this section.
Yeah. All right. That's it for today. Next week, 9 to 11 in this classroom, we review a lot of stuff.